Hello guys and welcome to Quick Tip Academy. Today we will learn a quick tutorial on how to utilize exhaustive enumeration on Python. Exhaustive enumeration is an algorithmic technique where we test all possibilities until we arrive at an answer or we exhaust all possibilities. In this tutorial, we will show a program written with conditional statements only, explain its limitations and illustrate how exhaustive enumeration can be applied to write more robust programs. For this tutorial we will use the Spider 5.1.5 Python development environment. Displayed is a list of functions, conditional statements and operators used in this tutorial. Refer back to this section at any time in the tutorial. Let's write a code to return the largest even number from a set of 3 numbers. Adding the hashtag symbol means Python will skip the text after the symbol on that line. This is important in writing any useful information within our lines of code. First, define a variable using the def function called largest_even and collect our 3 numbers as x to represent the first number, y to represent the second number, and z to represent the third number. Note, every even number is divisible by 2 to give a remainder of 0. Hence, the modulus function is used to test if a number is even. Using the if conditional statement, the line of code is written to test if x is even and y and z are odd. If x modulus 2 equals 0, and y modulus 2 is not equal to 0. And z modulus 2 is not equal to 0. Since x is the only even number from the set. If y is even and x and z are odd, write the code. Elif x modulus 2 is not equal to 0. And y modulus 2 equals 0. And z modulus 2 is not equal to 0. This should return y as the only even number from the set. Similarly, we test for z as the only even number from the set. Next, check if all 3 are even. Then we check the largest between all 3. If x is greater than y and z, return x. If y is greater than x and z, return y. If z is greater than x and y, return z. Next, we check if two of the three numbers are even and the last is odd. Say x and y are even. And z is odd. Then the answer will be the largest number between x and y. If x modulus 2 equals 0. And y modulus 2 equals 0. And z modulus 2 is not equal to 0. If x is greater than y, return x. If y is greater than x, return y. This checks the largest number between x and y. Similar lines of code is written. If x and z are even, and y is odd. And if y and z are even, and x is odd. Lastly, write a line of code if all numbers are odd and return a print message, no even number entered. Type #% to close the cell. Now run the program on the Python console. Type our defined variable largest even and enter a set of numbers. 2, 4, and 6. This returns 6 as the largest even number from the set. Test another set of numbers. 56, 99, and 1248. Lastly, we test as set of all odd numbers. We receive a message, no even numbers entered. We can quickly see that the codes work, but we had to write 30 lines of code for a simple task involving only 3 data inputs. We would encounter various challenges if we needed to solve large inputs. Challenges could include requiring much longer time to write so many lines of code, codes becoming more prone to error and more difficult to debug, slow and bulky applications, writing code for very large datasets become near impossible, etc. Exhaustive enumeration helps to eliminate or mitigate these challenges. To utilize exhaustive enumeration, we want to collect a list of numbers. Let's collect this list in a variable called numList. NumList equals list, bracket. Insert an input function to give the user a prompt and enter message enter number. .split function will separate the data input into a list. Default separator is a space. Insert the int function to convert all the input in the list to integers. Lastly, on this line of code, insert a map function to the list to ensure the list is iterable. Ensure to add brackets at the end of the line to enclose all functions. On the next line of code, define a letter j to calculate the length of our data list numList using the function len. Next, define the letter x equals 0. Next, write a code, numList.sort, reverse, true. This will arrange the data list numList in descending order. add text to the lines of code proceeding with the hashtag. Next, add the conditional statement. While x is less than j, column, enter. If numList x, modulus 2 equals 0. To test if the first number in the arranged list is even. Print number list x. To print that number. Break. Then add the incremental code x equals x plus 1. Remember, the third line of code was x equals 0. Thus, the incremental code x equals x plus 1 will replace x with 1, then 2, then 3, and so on for every iteration. This will test the first number on the list, then the second number, then the third number, and so on, until the condition is met. Next, we write a code. If x equals j, meaning all numbers on the list have been tested. The list is exhausted. Remember, j is the length of the list. This means that all the numbers in the list have been tested and none have met the condition for an even number. Print. No even numbers entered. Finally, close the section of code. Similarly, write text to define the meaning of the lines of code. We can clearly see we have achieved same task with 11 lines of code using exhaustive enumeration as opposed to over 30 lines using only conditional statements. Also, this is not limited to only 3 data inputs. Now run the code for the same entries tried earlier. Finally, we see with exhaustive enumeration, we can write an infinite number of entries. Thank you for learning. Please like, so others can benefit from this tutorial. And don't forget to subscribe for more quick tips.